Hey guys, it was good seeing you in our chat today. Yeah, it was really nice. I miss you, and I like you guys, and I don't like anybody. So, we're going to be looking into section 1, 2, and 3 of chapter 5, which are the normal distributions. I'm going to show you how the chart worked, and you can try some problems for yourself. I'm going to start on page 243. And I'm going to do 22, 24, 28, 32 all on that page. And they'll go pretty quickly. But you'll have to have your book and you'll have to have your chart that says normal distribution. It kind of looks like this, the title. And it could be found on page, I think it's A16 or something. And there's two sides to it. There's a negative side and there's positive z-score side. So we're going to be looking at both of these. So on page 243, what we're eventually going to need is this z-score formula, which we saw way back in chapter 2, I think. And it's found on page 237 if you need to look that up, where this is any random score. This is the score. This is the average. We'll call that the mean. And this is the standard deviation. And we'll need that in a bit, but let's see how the chart works first. So on number 22, they give us this problem that looks like this, and let's see if you could look at it with me. They want the area that's between a z-score of 0, which don't forget, average is right down the middle and has a z-score of 0, and a z-score of negative 2.25. And they're asking you, what is the area of that shaded part of this normal curve? Well, doesn't it make sense that anything to the left of 0 is going to be 50%, all of it? So it's going to be 50% minus this little bit on the end. But we need to find out what is the area of that little bit, and the table will tell us. The table is designed to give you all the areas to the left of a particular z-score that you're looking for. So if we look for negative 2.25 on here, I don't know if you can see this, but it's negative 2.2 is right there. We go over to 0.05, which is right here. So look at on your own, and that number should be 0.0122. Make sure you look at your own chart, you just don't go by mine. So for this number 22, that part to the left of that z-score of this negative 2.25, this part right in here has an area of, what did we say? It was 2.25 is 0.0122. Now, anything to the left of 0, which we'll put right down here in blue, anything to the left of here, all of this blue area is got to be 50%. I mean, you can look up a 0 z-score in the table and it'll show you 0.5. And then this pink area here is this pink area in here is the 0.0122. So if we go 0.500 minus the 0.0122 and we subtract them, we'll get the answer, which comes out to be 4878. 4878, which makes sense that this blue area in between here is almost 49%. So it's the 50% minus that little bit. So take a look at that one again. Let's look at number 24. Number 24, it says they want all the area to the left of a z-score of negative 3.16. Now the negative z-score appears over here because it's to the left of average, which is right in the middle, which has a z-score of 0, and they want this area in here. So see if you can look it up in the chart and get this number. It actually comes out to be 0.0008. Take a second and look that up. But you're looking up 3.1 and then sliding your eyes over to the 0.06. So 3.1 is right here. I'm going to slide over to 0.06. Oh, I'm on the wrong one. There's our point. I don't know if you can see it or not. You'll have to look at it. But you're looking at negative 3.1 over here and sliding over to 0.06 and it's 0.0008. We get that. Number 26, if you're looking at 26 in your book, no, not 26. Let's do 28. It says, to the right of a z-score of 3.25. So this is the middle. Z-score of 0, 3.25. And they want the area to the right of this, which is over here. So they want that area. How much area is that? Well, the table only gives us values to the left of the z-score. So we'll look up the z-score, but understand that the table is going to give us all this area in here, all of this. The whole area is 1, so whatever we get when we look that up, we'll have to go 1 minus that to get the pink area. And if I look up 3.25, I'm going to go 3.2, slide my eyes over to the 0.5, which it comes out to be 0.9994. Make sure you can find that. This blue area is 0.9994. But we don't want the blue area, we want the pink area. So if we go 1 minus this blue area, like my colors, 9994, this should equal the pink area, and we'll get 0.0006. This is the area of that pink area there. Let's do one more where we're going to find the area in between. And the area in between, so number 32, say, says find the area in between a z-score of negative 1.53 and a z-score of 0, which is right down the middle. So normally we'd have to look up two things. Matter of fact, let's do so this one would be just a 0.5 minus whatever we get for this, which is a negative 1.53. And if we look up negative 1.53, we are going to get 0630. 0630. That would be this area over there. From everything from the 0 over is 50%. That's why it's 0.5. They always do 4 decimal places. And the answer to number 32 would be 4370. You could use a calculator to subtract those. So that's how you would find in between. Sometimes you have to, let's do 34. We'll look up 2 of these because they want the area in between a negative 2.33 and a positive 2.33. Where 0 again is right down the middle. And if we look up a negative 2.33, let's say, you look it up, you should be good at it by now. 2.33 in our chart is going to come out to a 0099. That's this area right here, 0099. All of this area to the left of this. And then a positive 2.33, I bet it's going to be the same thing on the other side, but if we look up the positive 2.33, it comes out to be 9901. So let's write this, so all this pink area then, right in here, everything is going to be 0.9901. So let's just say the black area over here this is the area here which we get the 0.0099. If we want the area in between, which we'll say is our blue area, all this, do you see how the pink minus the black will equal the blue? So all we have to do is this 0.9901 minus 0.0099 and do that in our calculator. And it comes out to be 9802. That's the amount of area that falls in the blue region. It's the pink minus the black. So let's go to section 5.2 where they actually ask the question backwards. So let's see. Let's go to section 5.2 and let's look at what they're asking us here, and maybe we'll even start by doing an actual problem. Let me see the next page. Yeah, we'll do an actual problem here. So problem number 8. We're gonna look at problem number 8 on page 249. And let's see what this problem says. If you turn to that page in your book, it says the heights of women. So in a survey of U.S. women, the heights in the 20 to 29-year-old category were normally distributed. That means they fit under a bell-shaped curve with a mean of 64.2 inches and a standard deviation of 2.9 inches. So they're telling us what the mean is, and they're saying it's 64.2 inches with a standard deviation of 2.9. So it says find the probability that randomly selected study participant has a height that is less than 56 inches. So they want, what's the probability if you just chose someone out of the crowd, it was less than 56.5 inches. That's what we're looking for. Well, this 56.5 is under this curve somewhere. It's less than average because average is right down the middle with a z-score of 0. This is less than average, so I know that it's got to be to the left over here somewhere. That's where my x is going to be. But in order for me to find out how much, I need a z-score. That's where I go to my z-score formula. And that z-score formula was at the top of the page here. So we got our score, which is 56.5. We're going to subtract the average and divide by the standard deviation, and we're going to get a z-score for that. So if you use your calculator and you do that, let's see how that works out. We're going to go 56.5, do it with me, 64.2. We're going to subtract those two and then divide by 2.9, and we're going to get a 2.66 negative if we round it. So this is a negative 2.66. What we're interested in is the area to the left of this, but based on what question they're asking us. So let's look at this question, number 8. What are they asking? What's the probability that a person at that height is less than? So what's the probability they would fall in here because they're asking less than this height? And this is the 56.5 inches. What we would do is go to our table, look up a negative 2.66. Let's do it together. Make sure you're looking these up, and if you need time, just pause the video. 2.66 is a 0039. This area is 0.0039. So it's a very small chance that you would find someone that's 56 inches tall. Now 60 inches is what, 5 feet. So this would be 3.5 inches short of 5 feet. So it's a very slim chance that you would just walk down the street and choose somebody that would be that tall. But part B to the question says, what's the probability that the person that you chose is somewhere in between, bigger than 61 but yet less than 67? Oh, this is a new type of problem. This is an in-between problem. Again, average is in the middle. The z-score is always 0 there. We're interested in this score. Well, average was 64, right? 64.2. So 61 is going to be right about here. We'll call this x1. And over here, 67 is someone who's 5 feet 7 inches. We'll call that x2. And we want this area, I'm going to make it black, right in the middle here. That's the area I want. But the chart won't give me that area. The chart will give me, if I look up a z-score for 61, it'll give me always to the left of the score I'm interested in. And then this other one, when I look that up, it'll give me everything to the left. So it'll give me all this pink area all the way down here. And you can notice that the pink minus the blue is going to give us the black, right? So let's look up a z-score. Oh, we don't have a z-score. So we have to go to the z-score formula, which was on page 237 right here. It's our score minus average divided by the standard deviation. Our score minus average divided by the standard deviation. This is x1. x2 is going to be the score that we're interested in, minus average divided by the standard deviation. Now, if we did both of these, it would come out to be, let's see, 61 minus 61.2 divided by 2.9, and it should come out to be negative 1.10. That's the z-score. Oh, I'm sorry, this would be z1 and z2. This is our x1 and x2. So this would be z1. z2, if we did that one, let's see, it would be 67 minus 64.2 divided by 2.9, and here we're going to get a 0.966, I think. So almost a 0.97. So let's call this one approximately 0.97, because the chart always does 2 decimal places. So let's look it up in the chart, and we'll look up these two numbers. A negative 1.10 is going to be 1170. So the blue area is going to be 1170. Right in here. About 11, almost 12%. And then the pink area, all of this area to the left of the 67, we have to look up 97 in our chart, 0.97. So we go to 0.9 in our chart, and we go all the way over to 0.07. That would be 0.97. It would be over here. So we would get an 8340 for the pink area. If we want the area in between those two, we would have to subtract those two numbers. So the pink number minus the blue number will give us the black number. And that answer would be for number 8, 6983. What does that tell us? That tells us there's about approximately a 70% chance that if you chose a woman off the street, she'd be somewhere between 61 and 67 inches tall. So this video is running kind of long at 17 minutes, so we're going to stop here, and I'll do section 3 in another video.